Thank you guys for having me. It's usually a different audience that I deliver the talks, but I thought that I wanted to bring the infrastructure layer and blend within the DeSci community. So hopefully the information that we will bring today, you should take this presentation as an invitation to collaborate and think about the data and the storage in a different perspective. And I wanted to speak about the potential bottleneck that is becoming more important for DeSci. So not only who is funding the science, owning the IPs, or coordinating the research, but who also gets to learn from the sensitive data. And I wanted to start the talk by why I was incredibly inspired to come to this community to share about decentralized storage and how it could potentially be the solution. I face this issue myself very personally. I have incredibly rare genetic disease, and patient one that was diagnosed was my sister, who is a legal Swedish citizen. And when she got diagnosed, I am Lithuanian citizen based legally in the Netherlands. My parents are still based in Lithuania. So all of a sudden we had 3 different countries that needed to communicate because this genetic disease, vascular EDS, is so incredibly rare that in order to access testing, you need to provide a paper trail of work that you have a right to the test. And I had to learn a whole lot about it. And this was the process that took me around 2 years to get the right papers to get access to be tested. And unfortunately, the test was positive. And I spent 2 years just to get the result. And after I was tested positive, it took another year for the medical data to be transferred to Lithuania to my parents so that my parents can also get the proper testing. So it is odd that, at some point the testing depended on the medical records from a close family member that was living abroad. And what stayed with me is that even when the data finally was moved, I could not clearly know who had the copy or who had the access to be stored it. Because I went through different, more private institutions, and then I tried the public health system. They all had different ways of trying to share the data. And it was shocking to me that I spent over a year trying to go through very official channels. And then when I went to a private clinic, they said, just send over the documents over an email, and that will be more than enough. So when I realized that indeed my health data now was in many different sources of the data storage, I realized that I unintentionally lost access and understanding who will ever have this data. Would I move to Sweden and then all of a sudden realize that my health insurance is more expensive because Sweden also has access to my data? I still do not have that answer. And that's why I do think speaking about decentralized storage and how it could potentially solve this issue that I was facing could be the step forward. So to me, the question is simply not how do we open more data, but the better question is how can DeSci community create infrastructure where research can learn from the data without owning the data, and I would be, at the end of the day, in control of understanding who will be able to extract and have access to it. So to understand why this matters now, we need to look at where the DeSci and you guys have been progressing in the last years. I think this is my 3rd DeSci, and it is incredibly to see that the funding rails that you have achieved and the IP ownership rails, the DAO coordination, super awesome that someone is giving another workshop close by. The vast exponential move in the AI agents and the execution and the discovery has been moving forward. See, but as agents become more capable, the bottleneck shifts. And it is no longer only about funding the research, coordinating the people, but where are the systems allowed to compute over? So especially when the data is sensitive, personal, or regulated. So this last layer that I'm trying to explain, the data and computational rights, it may become one of the biggest challenges in the infrastructure from the user perspective as well. So who is allowed to run the analysis, the models, the queries, the algorithms for the sensitive health data without necessarily owning it, downloading, or seeing the raw data? So in traditional health systems, the default was that hospital platform, then researcher, the insurer, or even AI company, they get the access to the data set, and then they compute over it and they extract the value. But in the vision that I'm here to discuss with you in more privacy-preserving health data variation model, the question becomes more political and more infrastructural as well of what technology we're using. So can useful computation happen when the data stays under the patient and community control? And is it even possible to do so on a very technical level? But before we talk about the computational rights, I want to slow down and talk about what owning the data truly also means. So when we say data ownership, we often imagine it who owns the data set, right? At the end of the day, when I was transferring my medical data from Sweden to the Netherlands, in theory, I own the data. It is my data. But the ownership can hide inside the infrastructure. So when we talk about the data, we should not only ask who has the legal claim. We should ask who controls the actual conditions of the use. Control appears wherever access, discovery, copying, computation is mediated. So there is where health data becomes the clearest example, because the health data, the tension is not abstract, right? It is not theoretical fight between openness or privacy. Both sides, they face the legitimate issue, and I do think that researchers really do need way easier access to the health data, but the patients, they really do need protection from extraction. This is why the health data in this very case, the tension between the user and extractor becomes so important. So indeed, this just showcases that I today do not have any control or knowledge who has the cached copies of my medical data, who has the access paths. If one person that is on their work email, lingering the email in the back end, if they leave the company, would all of that data information would be wiped? Again, I don't have the trail of it. I don't have technical or even theoretical way of understanding it. So since the health data makes this tension impossible to ignore, because both sides need the access, I just kind of wanted to look at the researchers that has the real needs, and that's most of you, right? You need the longitudinal records, cohort analysis, and then AI training signals, the public health statistics. But then as an individual, we also want the privacy, the consent, we want the revocation rights, and also the contextual integrity. As I said again, just sheerly understanding whether my records will be shared. And also protection from extraction. So this is why health data is such a strong example, specifically when it comes to decentralized storage. And the problem is not that either the researchers or the patients are wrong. I think both needs are very valid at the same time. So that means that not only access is the problem, it is also the computational problem. The health data is not a commodity, and within the EU regulation it is pretty clear on that. So one current answer to this problem is the idea of personal health data spaces that you see. So we had a Taltech, a Tallinn Technical University, and one of their professors, Thomas, conduct a very on the surface research on his attempt to educate his colleagues as well. And it points toward the familiar DeSci ambition of patient-owned health data, spaces, decentralized content address storage, research reuse, solid-style pods, and AI or public health applications. So this is a useful direction because it moves away from the idea of the health data should live only inside one hospital and one centralized platform or institutional database. But I think it is very important in the context of the limitation framing here as well. Because I truly do not want this talk to come across that I am just pitching to decentralize the storage and the health data, because I also don't think that's a solid solution. So it can treat the health data, the PHDS, it can treat the health data as if it were one stable file or one unified record that only needs to be placed into decentralized storage. But the health data is not one file, right? The health data is a living space, and it tells the history about me and my family. It changes over time, and then new records are added. In my specific case, my genetic disorder has around average living age of 28. I have surpassed that, so did my sister. However, there is a vast difference in the conditions and the symptoms that me and my sister are experiencing it. And we're constantly updating our healthcare data to hopefully in the future also share with the researchers why in one genetic tree we have such a differentiating symptoms. So consent changes and the health records are constantly updated. And this is where I would like to introduce a little bit more this swarm architecture, the technical architecture, and a serious decentralized swarm as a technical solution implementation would not rely only on content addressable storage. So content addressing is powerful because it let us say that this exact file is this exact file. And if the file changes, the reference who changed it also changes. So this is very useful for integrity, citations, and verification, right? Whether I was the one that made the change to my health records, was it my doctor in the Netherlands, or was it a third-party doctor if I had an emergency today in Berlin and that doctor needed to change my health records as well. So since we established that the health data is not only a fixed file, the health data changes over the time and the records needs to be added. So we need a way to say who is allowed to publish if the data is the valid one. And this is where the COCs matter as well. And COC means single owner chunk. So that's something that comes from the Swarm technical infrastructure. And in simple terms, it is a Swarm's primitive to tie and update to a specific owner is instead of only asking what is the content, we can also ask who assigned this update. And then when those chunks are used together with feeds, they can support changing reference over time, like saying, this is the latest valid version published by this owner and validated by this owner. So for health data spaces, that matters a lot because the goal is not to just store the medical records once, the goal is to support the living owner control data space where updates can happen over the time. But since the PHDS it's not a bad idea, the critique is that it should not be imagined as a static data locker. It should be imagined as changing governed owner controlled data space. But when we look at the proposed architecture from more closely, we can also easily see decentralization can start behaving like the data bank. And this is where I, again, give the disclaimer of understanding that I'm not proposing only to decentralize the data, but understanding how we can even turn decentralized data eventually being centralized back. So on the surface, the architecture of decentralization is our healthcare service providers, decentralized storage network, they're all communicating, but decentralization at the storage layer does not automatically mean decentralization of power. And as I said, because it includes indexing, package, selling access to it, reusing the secondary research. So the question is not only if and is the data stored decentrally, but who controls the access paths. And the three assumptions that DeSci could challenge that I see is the first assumption is that fair automatically means ethical, right? Findable, accessible, interable, or reusable sounds good for science, but when the source of the data is person's body, fair has to be opt-in and not assumed. The second assumption is that encryption carries governance by itself. And encryption is important, but it does not decide who should access, under what purpose, for how long, and with what accountability. And the third assumption is that decentralization erases the power. The power can be moved to the keys, to the access of the paths and the cached, and the computation. So health data is not an ordinary data, and it is reusable only under strict conditions. So that means encryption helps, but it does not make governance disappear. The key issue is purpose, permission, and reidentification risk. This is the main conceptual shift. The research pattern is give me the data set, but if it moves into the central repository and then a researcher, institution, or AI model works on it, it's a different one. So that familiar model, but it creates a very strong power transfer. So once the raw data set moves, the person often loses meaningful control. So the better pattern is different. Instead of giving someone a data set, we define what they're allowed to do with it. What method is approved for what purpose, and under what permission, and under what result is allowed to be leaving. So the data access becomes computational rights, the raw data becomes verifiable outputs, the ownership becomes accountable use, and extraction becomes constrained learning. So this is my thesis that I leave to you as an invitation to come and join me in this research and a path that I say to bring the code to the data. So this is the analysis at the edge. Very simply, the data does not leave its protected space. The method travels to the data. The method has to be explicit and constrained, and only permitted result leaves. But it is important not to over-romanticize this proposal. And analysis was not invented mainly for privacy in IT, but it is often used because the data load is also so high and incredibly difficult to process it. So whether the data is a simple example, weather data, right? So that's how it's currently set up, that the sensors generate huge amounts of raw measurement data, and then it would be inefficient to send every raw measure of this data into the cloud. So before doing anything useful with it, some analysis happens locally. So trying to wrap it up, right, just a moment. So this is the research question that we are proposing, and the output and the schema. Knowledge shared without the extraction. And these are the primitives where I want to kind of showcase where you can come into the Swarm universe and try to understand how it could be useful for your own project. Swarm should not be persisted as the solution, as I said, but more as the primitives that we've sent for accountable research objects. A research object is not only a paper, the manuscripts, the access rules, the citations. And this matters because science is not only about producing the result, it's also how we do that. So this is the idea from the protected source to computation and to travel the queries through the different pods. But protected computation over sensitive health data is not something we should pretend that it's already solved end to end. And in this model, data remains under the user or data space control. The algorithms become inacceptable, but access does not collapse into the central key holder. So this is why the idea of traveling aggregation or traveling accumulator matters. And this is the prototype that I propose that is worth testing and look into it. And I really would love us to learn from the data without taking the data. I will cut this a bit short, but if anything what I just said made any sense to you, I specifically did not put the link, the QR code to the websites of Ethereum Swarm. I put it directly to our Telegram. And if there is a demand and interest, we're more than happy to host a workshop from very technical to a non-technical perspective for you to learn about all of what I said and much more in depth. So if there is demand, we're more than happy to organize and meet you folks online or in person, because we do truly believe that there is a way of accessing the data without owning it. Okay, I will make sure that I personally give you guys the invite. Sorry, it was working earlier today, but I will give you the QR code if you come to me. Thank you.
Amazing. Thank you so, so much.